going to share with you my prediction for the topics that are most likely to be in paper 1 Edexcel IGCSE Chemistry Exam 2025. This paper is both for the double award or combined science and also for the separate sciences. So the first topic, which is a guaranteed topic in your exam, is the reaction rate, the graphs for the rate of the reaction, and also factor affecting the reaction rate. In the exam, they usually provide you with an experiment with some data and with a graph for the rate of the reaction. They may ask you to calculate the rate of the reaction from the graph or from the data provided, mostly from the graph, where that you need to plot or need to find the tangent at a specific time. And then you need to find the slope of that tangent in order to calculate the rate at a specific time. Sometimes they ask you to sketch the change in the graph if there some of the factors has changed, like the concentration of the reactant or the temperature and so on. Remember, if this factor increases the rate of the reaction, then the curve will be steeper, and if the concentration it changes, then the final concentration of the product will increase compared to the original curve. If the concentration remains the same, but for example, if you increase the temperature, the rate will increase. However, the final concentration of the product will not change. So you need to be aware of this when you draw your graph. And secondly, the different factors that affect the rate with explanation in terms of collision. So it's very common in the exam to find a question using the collision theory, explain what happens when this factor it changes and how does this change the rate of the reaction. You need to use the collision theory, you need to refer to the successful collisions and the frequency of collision. These factors are the temperature. Increasing temperature increases the rate of the reaction. Increasing concentration of the solution will also increase the rate of the reaction, and in case of gases will be the increase of pressure, and then also the surface area to volume ratio. So if you use a powder, the rate of the reaction will be higher than if you use like a big clump of the solid, and also the use of the catalyst. It's become very common in lately that they ask you about the use of the catalyst. How does the catalyst work? Remember that the catalyst increases the rate of the reaction by using an alternative pathway in the reaction that has a lower activation energy. So you end up with more successful collisions. It doesn't increase the frequency of the collision itself, but it increases the rate of the successful collisions because of the lowering of the activation energy. Remember as well that the catalyst does not change at the end of the reaction. The second topic is a water of crystallization, very common in the exam to provide you with an experiment where they use hydrated salt and they do dry it and collect the water of crystallization. In these questions, they usually ask you to calculate the number of water of crystallization within the hydrated salt. So for example, how to calculate X in magnesium sulfate XH2O using the masses of the anhydrous salt and the water. You need to convert these masses into moles and then see the molar ratio. Also, for if this question comes, which is very, very common in the exam, they would usually ask you to test for water. So they might ask you, because we collect water here in this experiment, so they could ask you the chemical test for water to prove that this is water that was collected. So you use the anhydrous copper 2 sulfate and it changes color from white to blue. Or they might ask you to use a physical test to test for the purity of water. In this case, you use boiling point. Ionic and covalent bonding, this is a guaranteed question in your exam. The most common questions in the exam, or the thing that they like to ask about in the exam, is to describe what happens in the electronic configuration when an ionic compound is formed. Remember, when you answer this question, you need to refer to that the metal would lose electrons and the non-metal will gain the electrons. They will form ions, and then you need to refer to the ratio between the metals and non-metal in the ionic compound. And also, they like to ask about the forces of attraction in covalent bonds. Remember, forces of attraction in covalent bonds, you need to refer to the electrostatic forces of attraction between the shared pair of electrons and the nuclei. And you have to use nuclei, not nucleus, otherwise you're not going to get the mark. The complete the dot and cross diagram for ionic compound or for the covalent, the one that is most common is the covalent compounds. You need to practice these. These are easy type of questions. And also explain the difference in the melting point between ionic compounds, covalent compounds, and giant covalent structures. Remember that ionic compounds have the giant ionic lattice and they have strong electrostatic force of attraction between the oppositely charged ions. They need a lot of heat to break these forces, so they have high melting points. Covalent compounds, however, they have weak intermolecular forces of attraction between their molecules. This is why they have low melting points and boiling points. However, giant covalent structures, when you melt the giant covalent structures, they are giant, so you need to break the covalent bond. In simple covalent structure, you don't break the covalent bond, but in giant covalent structure, you break the covalent bonds. This is why you need a lot of energy to break these bonds. A giant covalent structure themselves hasn't been in the exam in the last exam, so I would think that it will be in the exam this year. And in giant covalent structure, we need to focus on graphite and diamond. You need to know that graphite conduct electricity because of the delocalized electrons, while diamond doesn't, and also they both have high melting point. You need also to know the difference in the physical properties, that graphite is soft because of the layers and weak forces of attraction between the layers. However, it has high melting points because of the covalent bonding. C60 fullerene is not a giant covalent structure. It's just simply a big covalent compound where it has a big molecule which has 60 carbon atoms. So you need to distinguish between C60 fullerene and giant covalent structure because it's not one of the giant covalent structures. Organic chemistry is all about hydrocarbon for this paper. It's very common in the exam, and the topics I'm going to talk about now in the organic chemistry are the ones that are almost in every single exam. So remember that hydrocarbons contain carbon and hydrogen only, so they might ask you which one of these compounds are hydrocarbons and why, because they contain carbon and hydrogen only. So if there is any oxygen, nitrogen, any other element, they are not hydrocarbons. Remember that alkanes are saturated hydrocarbons because they don't have any double bond. This is very common in the exam to ask you, while alkenes, they have this double bond, so they are unsaturated. Since they ask about the saturation and unsaturation, they're going to ask about the addition reaction for the alkenes. Test for the double bond or test for unsaturation. This is the bromine water test. Remember that bromine water test, where bromine water will change color from orange to colorless in case of alkenes only, not in case of alkanes, because alkanes do not react with bromine water. There is no addition, it's saturated. And then the substitution reaction of alkanes using bromine and UV light. So in every single exam, they always ask about this reaction. They ask about what is the reaction called. This is called substitution reaction. What are the products? So it's a bromoalkane plus hydrogen bromide as well as produced. And they ask about the conditions. So it's the use of UV light. Homology series, they love to ask about homology series. Remember that homology series are series of compounds that they all have the same general formula, they have the same functional group, and so they have the same chemical reactivity, they react the same, but they have gradual variation in their physical properties, similar like alkanes and alkenes. So these are two different homologous series. And also isomers. Isomers is a guaranteed question in your exam. So they love to ask about isomers, and remember that isomers have the same molecular formula, but they have different structure formula. Sometimes they ask you to draw an isomer for a certain compound they provided you with, or they give you two different isomers and they ask you why are these isomers. You need to distinguish between empirical formula, structure formula, and displayed formula because they might ask you to draw one of these or to deduce the or find the empirical formula for certain compounds. And finally, addition polymers. So addition polymers is almost a guaranteed question in your exam. So addition polymers is the addition of the alkenes to give you hydrocarbon saturated one along chain one. And they might ask you just to draw the addition polymer, how does it look, or to find the alkene that came from that polymer and the disposal of the polymers. So remember that addition polymers are not biodegradable. It's not easy to dispose them. Crude oils, fuel and crude oils, these are quite common in the exam, but they are not in every single exam. It wasn't in the last exam. There was nothing about crude oil and the fractional distillation of crude oils. So I would expect it might be in the exam this year. So what do they like to ask about crude oil? Mainly when they get you the fractional distillation, they like to ask about the different fractions and to name the fractions. So please memorize the different fractions that come from the fractional distillation of crude oil. Remember that fractions have different boiling points as you go up in the fractionating column, the boiling point is less. So the smaller ones with the lower boiling points will be collected at the top of the fractionating column. As you go down, the boiling points viscosity as well increases. If they ask about the crude oil and fractional distillation, there will be a question about cracking as well. So they might ask you to complete an equation for cracking, and also remember that cracking is a breakdown of long chain hydrocarbon to get the more useful shorter chain hydrocarbons, which can be used as fuel. And also one of the products is the alkenes, which can be used to make polymers. It's very common to ask you to name the catalyst used for the cracking, which is alumina, or you can say silica, so either alumina or silica. The fuel combustion and problem associated with the products of the combustion of a fuel or burning fuel. At least one of these will be in the exam. Sometimes they ask you to differentiate between complete and incomplete combustion, complete an equation. Remember that complete combustion produces carbon dioxide and water only, but incomplete combustion, you're going to have carbon monoxide in addition to the carbon dioxide and water, and sometimes carbon particulate or soot. The different gases emitted by burning fuel or the different pollutants emitted when we burn fuels and their associated impact. At least one of these will be in the exam. So remember that carbon dioxide causes global warming. Carbon monoxide is a toxic gas and it causes suffocation. This is produced from incomplete combustion. Sulfur dioxide and nitrogen oxides are also produced. Nitrogen oxide is produced from the car engine because of the very high heat, where nitrogen and oxygen from air combine to give nitrogen oxides. Sulfur dioxide is produced because the fuel contains some sulfur. So when you burn the fuel, sulfur dioxide will be produced. Both of these will cause acid rain and respiratory problems. And finally, soot, which is the carbon particulate that comes from as one of the product from incomplete combustion. This causes global dimming and respiratory problems. Qualitative analysis. So these are the chemical tests that you use to identify gases, anions, or cations. It become very common in the exam lately that they give you a question with a certain compound, ionic compound, and ask you to identify the two parts of the ionic compound, the cation and the anion. Sometimes they provide you with several ones and how to differentiate between them. So you need to revise the test for all of the gases, anions, and cations. So let's have a quick look at these ones, the one that you need to know. So first, the test for hydrogen, it gives a squeaky pop sound with lit splint. Oxygen reignites glowing splint. Chlorine bleaches litmus paper. Carbon dioxide turns lime water cloudy. And then ammonia will turn the litmus paper blue. If you have ammonium ion, then you heat it with sodium hydroxide, where ammonia gas will be produced, and it turns the damp red litmus paper blue. Test for metals, the flame test, you need to memorize these ones and the different colors for the different metals. And then we have the sodium hydroxide test, which distinguish between the copper 2 ion, which gives blue precipitate, the iron copper 2, the iron 2 ion, so Fe2 plus, which gives a green precipitate, and then iron 3 ion, which gives a brown precipitate. And finally, test for anions, test for halides, chloride, bromide, and iodide. This is using silver nitrate, where chloride gives the white precipitate, bromide cream precipitate, and iodide will give you yellow precipitate. And test for sulfate, where the first you add the dilute hydrochloric acid, followed by barium chloride, and a white precipitate will form if you have sulfate. And finally, the test for the carbonate, which is by the addition of dilute acid, where carbon dioxide is produced, you will bubble the gas through lime mortar to test for carbon dioxide gas, as we said before, and lime mortar will turn cloudy. Math skills. So there will be several calculations in your exam. The most common ones are the calculation of the relative atomic mass using the abundance of the isotopes. So they will provide you with different isotopes and their relative abundance, ask you to calculate the relative atomic mass. Find the empirical formula using the percentage composition of different elements in a compound. Very common in the exam. Please try to practice some of these questions to know the technique. Calculate the maximum amount that can be produced from a chemical reaction, as one of the reactant is the limited reactant, meaning you are using one reactant and reacting it with an excess of another one, and they ask you to calculate the maximum amount that can be produced as one of the product. Usually when you do this calculation, you need to convert everything into moles first. Use the balanced equation to see the molar ratio between the reactant and the expected product, and then calculate the number of moles of the product, and then convert the moles into a mass. Calculation of the enthalpy of combustion or of the enthalpy of a reaction, basically how much energy has been produced or taken in during the reaction. It doesn't have to be combustion, but combustion is the most common one. Remember the equations, Q equal mc delta T, and the value here is in joules. So we find the Q here, the heat, in Q, and then the molar heat or the molar energy transfer, which is the delta H. So this is going to be the Q, but now we need to convert this Q from joule into kilojoule and divide this by the number of moles of our product, or the number of moles of the fuel that has been burned. Remember as well that when it's combustion, or when the temperature increases, then the value of the delta H is going to be negative value. So in this case, when you calculate or when you find the delta H, you have to put it as minus, not as plus. But if the temperature decreases, then the value of the delta H will be plus. Usually, or most of the time, the temperature gives you an experiment where the temperature increases, so you need to use the negative value. Remember the conversion into kilojoule as well. Gases in the atmosphere. So this topic, what is common in the exam in this topic? To determine the approximate percentage by volume of oxygen in air using a metal or a non-metal. Very common in the exam to provide you with this experiment and ask you to calculate the volume, the percentage by volume of oxygen in air. The thermal decomposition of metal carbonate, including the copper 2 carbonate. It's not very common in the exam, usually very small question where they ask you to name this process, which is called thermal decomposition, and might ask you to write the product of the thermal decomposition. These are topics which are common, but it's not in every single exam. So, state of matter. So, state of matter, if it comes in the exam, it's quite common, to be honest. And if it comes in the exam, usually it's the first question in the exam. They ask about the different conversions between the states, and they sometimes ask you about a particular state, like the gas or liquid or solid, how the particle, the arrangement of the particles, and so on. And they may ask you to sketch as well the solid or the gas particles or the liquid particles. Calculating the number of protons, neutrons, and electrons using provided mass number and atomic number. As well, one of the topics that comes in the exam and usually at the top of the exam. Sometimes they give you a table with atomic and mass number, ask you to calculate the number of proton, neutrons, and electrons. Please watch out for ions. If they provide you with ions rather than with an element, you need to account for the charge of the ion, whether it's going to be a positive ion or a negative ion when we calculate the number of electrons. Naming ionic compounds and formula of ionic compounds using provided ions. There was a table in the exam, in the last exam, which was in November 2024, and they provided the students with the table with different ions with their charges and asked them to write the formula of the ionic compound. They like to ask these type of questions, but I don't think it will be in the question this time. Displacement reactions for metals and halides, reactivity series, and redox. So reduction and oxidation in terms of losing and gaining electron. These are not one of the very big topics in the exam, but it comes in the exam quite common, not in every exam though. So you need to know about the displacement reactions, how the more reactive metal displaces the less reactive metal from their salts. You should be able to write the equation for that. Also the halides, how the more reactive halogens will displace the less reactive ones from their salts. Like chlorine can displace the bromides, but bromide cannot displace the chloride. So these type of reaction you should be aware of. Also, they might ask you which one has been oxidized, which one has been reduced based on the loss and gain of electrons. So remember, oil reg, meaning oxidation is loss of electrons and reduction is gain of electrons. Alkali metal reactions and the rate of their reactions. So alkali metals, which are group one metals. Again, this is not one of the very long questions. So this is one of the small topics that you might find just one small question in the exam related to it, or they might provide you with an experiment and ask you to deduce which one is more reactive and so on. And for example, they might give you the reaction of alkali metals with water, for example, and they would ask you what would be the product as metal hydroxide and hydrogen, and then they might ask you to test for how to test for the gas produced, how to determine which one is more reactive, things like that. These are not very common in the exam though, but these two topics, 4 and 5, the displacement and alkali metal, something related to these topics should be in the exam. Rusting, they love to ask about rusting. So basically, the most important things that you need to know about rusting, which they like to ask about, is to name the rusting product, which is hydrated iron 3 oxide. How to prevent rusting, remember the use of barriers and the galvanizing using zinc. And remember that rusting needs both oxygen and water to occur. And making salts, especially making soluble salt. So sometimes they give you this as a whole 6 mark question to plan an experiment to make a particular salt using an alkali, using a base, and using acid. So how to separate this salt, the salt at the end, how to use crystallization to separate it, or to obtain or to get the pure salt at the end. Sometimes also they ask about making salts which are insoluble using different soluble salts. So I would make sure that I know this topic because it's quite common. It's not in every exam though, but it's quite common. So I would make sure that I know it. Separation of component of a mixture. This is not going to be a big question, but you need to know the different techniques because they are usually embedded within other questions. So remember that filtration is used if you want to separate an insoluble solid from solution, and crystallization when you have a soluble solid in solution and you want the solid. So you use crystallization. You need to know how to do crystallization as well because it's quite common to ask you how to perform that. Sample distillation, you use sample distillation if you want the liquid from solution of a soluble solid. So crystallization for solid, but the sample distillation for the liquid. And fractional distillation if you want to separate a liquid from a mixture of liquids. Diffusion is not very common in the exam, but it hasn't been in the exam lately, so I would think they might decide to bring it in the exam this year. And diffusion, the most important one in this reaction between hydrochloric acid and ammonia to form ammonium chloride. The type of questions that come with this one with these topics are quite standard, like why the ring has been formed more closer to the HCl than the ammonia, or the type of questions they usually come usually the same, or to ask you to write the sample of the different reactants and product from the reaction. So they are quite standard questions. Chromatography, it's not very common in the exam. It was in the exam last time. For me, it's less likely to be in the exam this year or this time, but I would never exclude any topic anyway. So they ask you to calculate RF or ask you to how to set up an experiment, and they would usually provide you with a chromatogram, ask you a few questions like which dye hasn't dissolved in the solvent, like here dye E because it hasn't moved, which dyes have the same components, things like that. So you need to refer to the RF or the distance traveled by the spot. Acid bases and alkalis, this is not one of the big topics in the exam at all, but usually they are kind of embedded within other questions. You need to know the pH scale, so they might ask you what do you expect the pH of the solution, this particular solution to be. So you need to be aware of that neutral solutions have pH of 7, acidic solutions less than 7, basic solution would be more than 7. And then the universal indicator, the use of universal indicator, the different colors at different pHs, and also the color of the different indicators in acidic and alkaline solutions. So the most important ones are litmus paper, or the litmus, the phenolphthalein, and also the methyl orange. So you need to know the color of these indicators in acidic solution and basic solution.